Hi, my name is Jake Barrison, and today I'm going to present on securing modern apps and VMware Carbon Black Container security. Brief outline for the agenda today. First, we'll put some bookends around the cloud application security layers and identify which layers are in scope for today's conversation. Next, we'll identify 3 pillars of a modern app security strategy. And we'll spend some time going through the CB container security platform itself, and then we'll wrap up. Depending on your team and your organization, you may be using quite a different variety and range of cloud providers and resources. But one thing that is true across all organizations is you can't focus on one of these layers up for security and solve problems across all of the layers. Each layer has its own complexities, has its own different stakeholders at various times in the application development lifecycle. And looking across the bottom, you may already be using many of these methodologies and tools to help you secure the various layers. Today, we're going to focus on the workload and container and Kubernetes layers, so the top 2, and primarily how CB container security helps bridge the gap between DevOps teams and the traditional security teams throughout the application development lifecycle and into runtime. So going from left to right, the first pillar we have is benchmarking and hardening. Key stakeholders are security and compliance. And this one is really focused on overall being able to reduce the attack surface. That's primarily done by incorporating automated compliance policies, which, if possible, can incorporate automated hardening rules and configurations to ensure that whether they're default weak configurations or misconfigurations are caught early on in the development process and don't make their way to production. And if they do, that they're easily reported on and bubbled up with a risk prioritized score. Next, we have the shift left DevSecOps mindset. This is a piece that incorporates many different teams. It is always going to be a work in progress, because ultimately what this pillar is about is building a channel of communication between traditional security teams and the platform developers and the application developers themselves. Being able to integrate security into the DevOps lifecycle is going to be a key component of having a modern application security practice succeed, because ultimately the amount of changes and the speed of change that is occurring with modern app development requires security to be built in. There's too much that happens throughout the pipeline to just be plugged in at the very end. So ultimately, building that relationship and being able to shift security into a DevSecOps mindset and build security in at each stage is one of the key pillars. Lastly, we have the cloud native detection and response. Key stakeholders here are security operations team members, as well as the traditional security analysts. And there are going to be some similarities in how teams can triage cloud native detection and response type telemetry. But what is key is the telemetry coming off of a K8s workload is going to have a different type of analysis done to it than a just traditional endpoint process. So the correlation is going to be a little bit different, and being able to have both the process correlation as well as the workloads vulnerability profile available. That is what really makes up the cloud native detection and response component. Again, with the key focus here to help the stakeholders help the SOC team members be able to act and articulate what they need from the rest of, whether it's the platform operators or other members of the application security team, and ultimately security analysts to be able to go to the other stakeholders and request or make the changes that they need to on their side. So keeping in mind that our layers of focus today are the Kubernetes and container workload layer, we're going to take these 3 pillars and start to dive into some of the CB container security components. And what we'll start with first is the container image scanning component. This is something that it's easily integrated into existing CI/CD pipelines. What we're looking at here is the reports that are coming back to the console, whether they're from pipeline scans, as well as the cluster itself has resources that are able to do additional scanning also configurable. There's additional details that we'll dive into within the console, but overall, this dashboard is a common place that both stakeholders from the security, application development, and others are able to access and share a common resource. Incorporating themes from each of the pillars, this is a view into the out-of-the-box benchmarking templates that are a part of the hardening policies in CB container security. These rules can apply to containers, workload configurations, as well as can be established around certain types of network runtime activity. So what teams can do is day one, they can, after deploying to a cluster or after integrating the CBCTL image scanner into an existing pipeline, they can use the templates that are available out of the box or create their own custom rule sets and immediately start reporting and alerting on findings that deviate from the rules that they've established. Going one layer deeper into how do these hardening rules function, many of them have the ability to alert or block. And in addition to those rule sets, there's also a subset that are able to do one additional type of function, which is enforce or mutate and set a pre-established resource configuration. Let's say if something isn't set at all or it doesn't meet a organization standards, instead of only alerting on that misconfiguration or blocking the deployment outright, Enforce is able to still flag it so teams can continue to track, but won't stop that deployment from occurring. Some of you might be thinking these colors aren't exactly where you want them to be, and you might be right. Block and enforce may make more sense to switch around, but ultimately I think having 3 identified different layers here is more important because there are rule sets that do allow for alerting, blocking, as well as mutating resources and the like. And the last piece to comment on before jumping into the console, what we'll also see is a network map. Part of the goal here is give a framework of what do these workloads and the communications actually look like? What are the current network connections? Give us some idea of the ingress and egress activity, as well as cross namespace connections. And inside of this, what we're also going to be able to see is the risk prioritized workload information, as well as any additional runtime and hardening violations that may be associated with a particular resource. All of that is going to be wrapped up into the network map page. And I'll also do my best to point out several of the pivots that this page offers. And let's jump into the console. Jumping into the CB Container Security Console, what we're looking at here is the Kubernetes Health dashboard. So keeping in mind the first pillar of benchmarking and hardening, this is a good first look into some of the resources that help make that easy for teams to do at scale. You can see that this is the overview. So I'm looking at all of my resources across all the resource types. If I pivot, I can go to the risks view for my Kubernetes Health. And what this does is, as it's already filtered by the risk score, this is giving a view into all of the workloads across my resources and giving me the risk prioritized list of which ones have the most risk associated. Popping open this right panel, we can see that we have one particular workload, the shopping workload, that has several configurations that are attributing to this risk score of a 9. The main one is this is exposed by an external load balancer, but the other contributing factors here combined with that top configuration are kind of adding up to a more significant issue, both being able to have a writable file system, allowing privilege escalation, and not having caps on CPU or memory limits. So this is a very quick view and one example of a risky workload that you can get right from the console. Some of the other facets on the left that you can see, you can quickly sort by whether it's resource, particular namespaces, in this case, whichever cluster you want to pivot to as well. And from there, we're going to pivot over to container images. What we're now looking at is a summary of all the container images and vulnerability information being reported back to the Carbon Black Cloud. This ties in themes from both the benchmarking and hardening pillar, as well as the turning more of a DevSecOps mindset pillar, because This does help teams gain and share more information about their container images and the vulnerabilities, but it also is a common resource between security and application owners to be able to share a common place to identify where changes need to be made. What we can do is over the top tabs, we can jump to image repositories, and we can see that you can search through any image repository and view all the images associated. In this case, I'm going to do a search for an image I scanned earlier today. And this one is interesting because overall, most images are going to report vulnerabilities, but with a new version of the CB container security, in addition to reporting vulnerabilities, if there is malware detected inside of a container image, that will also be reported. So jumping into this particular image to get that full information, we can see that not only is vulnerability summary details being reported, but there is also a file reputation finding. And in this case, if we jump to the layers tab, we'll be able to see layer by layer where vulnerabilities are introduced, as well as at which layer, in this case, the base layer, where a piece of malware was detected in the image. The suspicious files tab is where those types of findings get reported. So we can see in this case, here's the file of interest, it's an ELF file. And that reputation being critical is now a detail that the security team can share with the application developer team. And again, this is a common link, common console that can be a resource for teams to triage alerts that are either container images that contain critical vulnerabilities or images that contain malware. Now we're looking at a Kate's hardening policy. And this is super helpful for teams that are looking to do benchmarking and use out-of-the-box templates to help their team start to track early and often. And the templates that are available, there's a basic template, there's a CIS benchmarks 1.6.0 template, as well as a restrictive template. And then you have the capabilities to pick and choose any of the available rules from whether it's command-focused configuration controls, container images, rules around container images, rules around workload, network resources, and you can create your own templates depending on the resource and the applications that are in scope. A particular couple of rules to call out here for the container images, there's the ability to control and block or alert if critical vulnerabilities are associated. So this, in that shift left mentality, is a rule that is commonly implemented during the early build stages, where if a critical vulnerability is detected, as soon as possible, we want to be able to both alert and likely block a pipeline or block that image from continuing on into a registry or into further use. And that example or this rule is available out of the box. Some of the other rules that we also have already added to this policy that I'll actually drop back into view here. And if we go down to the quota section, I just dropped back a CPU limits rule. This is one example. You can also see there's a memory limits rule that has a value that's identified as a preset. We're going to spend a moment on this rule because it has the ability to both provide an alert for teams if there's a misconfiguration or a configuration that doesn't meet a team's baselines. It can block that resource from being deployed, or it can enforce a preset value. And this is where application owners or platform operators are able to work with the security team and identify what are the values that need to be set. Whereas if Kubernetes has provided a default, your organization might have a different default or want to implement a more restrictive policy. And this is one of the ways that certain policy rules are able to allow your team to do that. So in this case, I have already implemented a WordPress CPU default. So I know for my WordPress application, this is my WordPress policy. I'm going to enforce this CPU default and add that back over to the active policy. So now if I were to deploy this resource again, what I would be able to ensure is even if I didn't have the CPU limits, memory limits set, or memory limits set, those would be enforced with a preset. All these other ones you can see are set to alert actions. So there's no conditions at the moment that are going to stop this deployment from from reaching its end goal. But what I will receive is alerts if there are violations of any of these rules, and specifically will also be noted if there's any mutations that occur for the noted memory limits and CPU limits. So continuing to build off of that baseline and benchmark policy, what we're now looking at is the Kubernetes event stream, which is reporting back all events associated with whether it's the case hardening policies or container image policies. In this case, we're predominantly going to be looking at hardening rules. And in this case, you can see based off of the facets on the left, I could go ahead and I could filter directly for the alerting events, the events where an enforce operation occurred, or events where a workload was blocked from being deployed. In this case, we can already see the top two resources were actual mutate events. And if we open up the right bar on the WordPress deployment, we can see those two rules. And in particular, we were looking at the CPU and very similar memory limits restriction. And we can see that those two enforcement policies were applied and those resources were mutated. And that was reported right back to this Kubernetes event stream. Just like any other rule, these will be reported back into this stream. They can also be sent to a Slack channel or to a webhook. So if there's another repository or another channel that this type of information needs to be sent to, it's super easy to do that. But this is, again, sticking with the theme of creating a DevSecOps mindset. This is one place that can be a common ground to get this type of information. And from there, we're going to jump into a little bit more detail on the network runtime information. So last but not least, we're going to spend a few minutes on the network map. And what has really changed here is just the perspective. A lot of the resources and information that we've discussed so far can actually be seen on the right. And when we look at the network map, we'll see that right now we're associated with a particular namespace. But if I wanted to zoom into a particular workload, I'll see that the data changes on the right. I can see that workload's risk score. And just like we went through, I can see the hardening details and the network alerting details associated with that particular resource. This is a page that it's pretty dynamic. So you can come into this and see the network connections as they're happening and see the different resources and their relationships. And depending on who the person is that's in the console, there may be different pivot points that are more interesting to some than others. In particular, you can also use this as a place to pivot to workload risks, or you could pivot to the network runtime triage, as well as go in, and if you're more in the mindset of continuing to use those benchmarking rules and making sure that there's good reporting, you can go and continue to review the hardening policies. So all of that is bundled into this network map. Yet another common resource for teams to use as a single source of truth for what's happening in their clusters. And from there, we're going to go ahead and wrap up. So covered quite a few different details in just about 20 minutes. First, we focused in and zoomed into the container and workload layers, as well as the Kubernetes layer as the topics of interest for today. Walked through some of the key areas of how teams are mainly reaching for industry standards and easy ways to automate the benchmarking of their resources and how to make sure they can maintain compliance. Then we also focused on, in general, how does that practice, as well as enhancing communications between traditional security teams and DevSecOps or DevOps teams, help to reduce overall risk by accelerating that channel of communication and helping to avoid misconfigurations and hardened workloads. And last but not least, the ability to get those CATES events and the network runtime events into the hands of the security operators and make sure that they're able to have that telemetry, be able to map activity back to particular workloads and have that threat profile of those workloads during the investigation so that they can make timely decisions. hopefully this is a good starting point and a good overview to kick off future conversations about CB container security.